analyst is letting an oxygen go free.
I'm going to talk to you about air. Air is a little tricky because you can't see it, and sometimes you forget it's there, but it does not forget about you. And that's what we're going to talk about. Air impacts you all the time. It's happening right now. You're being impacted by air. And you might be thinking, oh yes, it's keeping me alive. I'm breathing. But that's not what I'm talking about. I'm going to be talking about how it's actually bringing you down. Actually, the first slide was an intro slide, so we can go there.
We're going to take a look at some of Becca's or Lauren's slides.
Oh, it looks, and through air bringing you down, by the end of this, hopefully you'll have this scapegoat about air pressure. So when you're feeling down or lazy, you can just blame it on air pressure. And I had this video clip of the guy from Rocky, and he's saying something like, I must break you. And I was going to be like, he's air pressure. That's air pressure right there to help you understand. But the video didn't work, so now we just get to look at him. That's air pressure. Trying to crush Rocky and you. And moving forward, what we're going to talk about is how much it's trying to crush you. So with that, we have this equation. Pressure is equal to force over a given area. And that amount of force over a given area is what we're going to try to find out, and how much the human body is taking on. And I'll give you a little bit more information. There is one more. 14.7 pounds per square inch is equal to 1 atmosphere of pressure. So that is the pressure part of this, 14.7. We're going to be figuring out the force side, because that doesn't really mean anything to us generally. So we're going to figure out how many pounds of force are on us, a typical human body, by figuring out the area. And to do that, if only I had like somebody covered head to toe in this kind of material that I could cut and then tear off. Oh, we have a knight in shining paper. What happened to your helmet?
With great fortune, we have someone covered in newspaper in the back of the webcast studio.
Here we go. Covered head to toe in newspaper. This is to represent every side of the body that is being impacted by air pressure. So that's all of you. All the parts the air touches is what is impacted by air pressure. And what we're going to do is cut this off, make it into a big rectangle, and then find the area of the rectangle, and that will be the slide's gone, but the area of the human body that's feeling that air pressure force. So we're going to go behind this. Oh, I need my scissors.
While we're grabbing scissors, Knight in Shining Newspaper. Can you tell us your name?
Dorothy.
And Dorothy, what brings you here to the Exploratorium today?
I'm also in the Teacher Institute.
And where and what do you teach?
I teach 6th grade math and science in Livermore.
Dorothy, I love your teaching outfit.
Here we go.
So
we'll be right
let's give it up for Dorothy, who came dressed in newspaper.
And it's cutting. And we're putting it in a rectangle. And all right, we did it.
Oh my goodness. Nice work.
Wait a minute. Okay. So this is representative of about a human size, average human. Dorothy is totally average.
Dorothy's a little above average.
Of the human body. All right, and this, when we find the area of this surface, it turns out to be, oh gosh, got a little messed up. It's supposed to say 2,800 squared inches, okay? And then if we plug it back into the equation, that 2,800 squared inches, it turns out to be about 41,000 pounds of force for that atmosphere of pressure. So one average typical person is feeling 41,000 pounds of force on you right now. If you're smaller, probably a little less. Then the next slide, she mentioned that van I drove around in. That's it, and that's me and my sister in it. That is, I did the math, and it's about 27 of those vans on you right now in pounds. Which is interesting. So luckily for us, I don't think this is going to work. Ooh, it's probably not going to work.
So lucky.
So lucky for us. what happens is our body is giving it an opposing force. Otherwise, air pressure would just crush us. And I was going to show you an example of that crushing force with these cans, but in order for that to have happened, these needed to be steaming, and it doesn't appear that that is happening. But basically, when you take a can with steaming water out of it, I was going to pick it up, flip it over in this ice water, and that would make those forces unequal, and it would instantly crush that can due to air pressure. And maybe at the end of the show I could show it. We'll just leave this going, and if there's steam, I'll come back out, and then you'll see it and you'll say, whoa, and then, you know, you'll be really impressed with me. So
there we go, Lauren Shane, who handled the pressure of a mishap
this happens
with the
all the
science
time in
of
class.
air pressure.
Okay, thank you.
That was great. Next up, we have from the High School Institute, Sue Miller. And Sue Miller's cheering squad.
Yes. Ooh. Okay. I do have one slide. Empty pipes. Now, there's nothing in here. Do you all see that? Nothing in these pipes. Nothing but our secret ingredient, air. So, one way I can show you that there is air in these pipes is I'm going to move the air. Did you hear that? So what's happening there when I hit this end, the air is going through and popping out the end. But then if it comes out, there's not enough air in there, so it goes back in and it goes back and forth. And we hear a sound. So what you are hearing, even when I'm talking, you are hearing air pressing against your ear at different levels. Now, see the size of this? We're going to see what happens when it's a bigger pipe. You hear how that is a different sound? So this is what's happening. When I hit the one end, I'm pushing the air through, and then it's going to pop out the other end, and we hear a sound. So now I need my trusty volunteers who practiced with me earlier.
Come on up, trusty volunteers. Can you say your name and where you teach?
My name is Dan Salisbury, and I teach at Ensenada High School in Alameda.
Thanks, Sals. I'm going to call you Sals.
My name is
and
Natalia. I teach physics in Costa Rica.
You had a long commute this morning.
And my name is David Garcia Ortiz. I teach biology at Sequoia High School.
Okay, so let's give you this one.
Welcome. Thanks for volunteering and helping out today.
So I'm going to have you guys go around the back so that the audience can see you. Now, first of all, I want you to hear the sounds. These are called palm pipes. So you can see by the different lengths, they make different sounds. Oh, these are called palm pipes, but let's look at the next slide. They're not quite as loud as those pipes would be. Can we get some organ music? Unfortunately, we couldn't get any pipes big enough to make that much noise. Well, actually, even those little pipes could. They just can't hit them hard enough to make that much noise. So now, with their pipes, they're going to play. Oh, could you hear their, did you have any trouble hearing their pipes when they hit them? Okay, good, because if you're having any trouble, you know, the outsides of our ears are to collect the noise. So if anybody needs any additional help hearing, you can put one of these on your ears. Anybody need a? Oops. So everybody's going to have to be really quiet. Let's go to the next slide so you'll know what you're listening to. Okay, are you all ready?
Yes, we are ready.
Okay, I will direct you. 1, 2, 3. You all have some natural pipes. Your mouth actually makes a pipe, and you change the size of it when you move your mouth when you're talking. And I do want you all to use your pipes later. There's an exhibit outside. There's a really, really, really long pipe out there. So find that pipe and practice making different air waves with your voice or with clapping your hands, and see what you can do with the air.
Wonderful. That was Sue Miller with how air moves through pipes in a mini advertisement for our Echo Tube exhibit, which is just right outside. Thanks, Sue. All right, next up we have our next contestant who is taking the Middle School Summer Institute today. Please welcome Becca Friedland.
Thanks, Julie. Hello, everyone. My name is Becca, and I teach in East Oakland. Can you make some noise if you're having a fun day at the Exploratorium? Woo! Fantastic. So today at the Exploratorium, you've been interacting with exhibits, you've been interacting with each other, and you might not have thought about it, but you've also been interacting with air. As we've discussed, air is all around us. We need it to survive. And as Lauren talked about, it's actually pushing down on you at all times. On your knees, on your arms, on your eyeballs. All of the air that is above you, a column of air that's going all the way up to the atmosphere, is pushing down on you. And per every square inch of your body, 14.7 pounds is pushing down on you. Almost 15 pounds, and that's really heavy. And just like Lauren said, overall, 41,000 pounds. That's insane. We can't feel it, right? Because our body is pushing back at exactly 14.7 pounds per square inch. So it balances out and you can't feel it. But what if you could? I happen to have right here this 1 liter bottle of water with a cube on top. And if you put it on a place on your body, you will feel what 1 unit of atmospheric pressure feels like. So 14.7 pounds per this square inch, right? So I'm going to pass this around, and you can feel, bless you, and you can feel what it feels like on your body. And it's heavy, right? It's not comfortable. And mind you, when you put it on, you're actually feeling 2 units because you're feeling the air that's already there plus this bottle, which is simulating another unit of atmospheric pressure. So remember, air is on you at all times, going all the way up to the atmosphere, and the weight of that air is pushing down on you, but we're pushing back. So I'm going to pass this around, and you can feel that. Okay, so we know that air is all around us. We know that it has weight, a lot of weight, and we know that it has force, right? And so that force exerted on a surface because of that weight is called air pressure. So we're going to see if we can use that air pressure to our advantage, what we can achieve using air pressure. So I'm going to need my trusty volunteers to come on out here with this large table. Thank you, Dorothy. We're gonna lift the whole thing, but keep these 2 together.
There we go.
Yeah, great.
Watch out on the front there.
Watch out in front here.
So you've heard of walking on water. but have you heard of walking on air or sitting on air, I suppose? We don't normally think of air when we think of lifting heavy objects, but maybe we should. So today, with the help of my volunteers and the air that they are able to exhale and the air that you all are able to exhale and the force that the weight of air actually has, we are going to lift this whole table plus my whole body on top of it.
No way.
Are all of the bags okay?
So
we
Becca,
are
what are
settling
they
in.
about to do?
So I am about to climb on top of this table, which you shouldn't normally do, right? But we are going to use it as an example to see how much force air can actually exert. So when I say go, all of my trusty volunteers are going to blow into the bags that are underneath this table. Just plastic bags, just straws. That's all that's there. Plus, of course, the air that they're exhaling. Which, of course, yes. So thank you, Julie, as we're holding up. This is a bag with a straw. So they're going to be blowing air in, and the air is going to compress, and we're going to see what happens and see if I can accomplish my dream of levitation. All right, are we ready? Are you ready? All right, on the count of 3. 1, 2, 3. Put that air in.
Think light thoughts, Becca.
All right, we're going up. We're going up. How are we doing? Woo!
There you go.
Fantastic. So I am now much more above, as is this table. How did that just happen? The air is being compressed in these bags. It's being pushed together, which is then exerting force on the bags, on the table. It's the exact same way your bicycle tires work, right? Pushing air into that so that the tires are big and sturdy and can hold you up and get you safely to work. All right, before my volunteers pass out, I think that's wonderful. Thank you so much.
Let's give them all a round of applause. They did not run out of air.
Yes. Great. And now, all right. Thank you so much, everyone. Have a
All
lovely
right,
day.
let's give it up for Becca Friedland showing the sheer force of air and how air can even lift you and a table up. Last up, we have a teacher from our Leadership Institute. Please welcome Don Larkin.
Okay, what do you think of when you think of air? Everybody breathe in. Breathe out. Okay, we're good? That's it? No, just kidding, just kidding. Just kidding, just kidding. Okay, so what helps you breathe? Just yell it out. What helps you breathe? Lungs. Right. Okay, that's what I thought I heard. And what makes your lungs work? Anyone? Yeah. Diaphragm. All right, I need a volunteer. Okay, you're cute, you're little, come on.
Hello, volunteer. Can you tell us your name?
Owen. Owen.
Thank you for volunteering today, Owen.
All right, okay, put that on. We're gonna match. I like to be twins.
In addition to matching clothes, you bear a remarkable resemblance, Owen, to our contestant, Don Larkin.
They say you tend to go after people that look like you. All right. So, Owen has lungs here on his shirt. But if I poke him, his lungs are still protected. What's protecting his lungs? Yell it out, yell it out. Your ribs, okay, okay. All right, carefully now. Let's get some ribs here. All right, easy, easy. Get those hands up through the holes. Very nice, very nice. So this is basically, it's anatomically perfect. And now, when we breathe, everybody breathe in with me. And breathe out. There's these muscles down here at the bottom of your ribs, underneath your lungs, and your muscles expand, and they pull air in through your trachea. All right, but you can't see the lungs very well, so let's take your ribs off. We won't actually take everyone's ribs off because it's not the safe choice.
Hands up high, hands up high.
Well, they've served their purpose, so that's okay. All right, so breathe in. Breathe. Breathe, boy. Okay. So the air is going into his lungs. It's red, represents air with oxygen in it. Goes all the way through to these little sacs called alveoli. And there's blood vessels attached to these sacs that take the oxygen out of the air. And yeah, you got plenty of oxygen. You're fine, you're fine. The oxygen's going through his body, and eventually there's waste. Not that kind of waste. The air without oxygen. What do we breathe out? Mostly we call it carbon dioxide. Now there's a lot of other stuff in the air too, nitrogen and whatnot. So back out, and exhale. Now, if this was a lung, anyone needs a lung, we have a spare so you can, and you breathe in. You see that balloon? And you breathe in. It's expanding like your lungs. And you breathe out. Any questions? Yeah? Awesome, you're good, you're ready for the test. Okay.
You ready? Thank you very much, Don Larkin, showing us what we do with air when we breathe in and out. Thank you, Owen, for your volunteering. All right, we are going to bring out all the contestants. Don, you can stay here because you are already here, but let's welcome back Becca, who's on the side chatting with another volunteer, Lauren and Sue. Come on up. I'm going to remind you what these folks did, and then remember, you have a wonderful job of applauding, and we're going to measure using a sound level meter the strength of your applause, and we're going to crown today's Iron Science teacher. So somebody's motioning to this. It is not hot enough, sorry, but we remember that Lauren Chang taught us about the force of air pressure all on your body. She calculated the surface of Dorothy's body and figured out how much air is pressing down. We had Sue Miller show us how air moves through pipes and how that makes sound. We had Don Larkin showing us what we do with air when we breathe it in and out through our lungs. And Becca showed us how air can be used to levitate a table and her weight. So air has force. So you guys ready? You have a favorite? All right, we're gonna do this by your applause. Please give it up for Lauren Chang. How about Sue Miller? Let's hear it for Don Larkin. And Becca Friedland. She levitated herself to the top. Today's Iron Science teacher, Becca Friedland. That's it. This is the last episode in this season's series of Iron Science Teacher. These folks are all participating in the Teacher Institute, which is finishing up today. Thank you all for coming. I hope you have a wonderful day at the Exploratorium. Enjoy the rest of your summer, teachers.